Based on the number of networks needed, means subnetted needed, number of departments, we did subnetting. This time we are going to do subnetting based on, okay, one more thing I would like to do. Not important, but some universities outside India, I think Iceland. I think there is a place called Iceland. There's a small island called Iceland. Next to Europe, somewhere in the. From there, one student wrote me mail long time back, many years back, like this. Sir, this is the network, say for example 10.0.0.0. If this is the network and let's say 10 bits given for subnetting, what will be the first 4 and last 4 network? Okay, this was the question. 10 bits. See, they have not given you how many subnets you need or how many departments we have. They simply say, hey, this is the number of bits I'm giving you for the sake of subnetting. Now you do subnetting. 10 bit will take really at least 1,000 subnet it will give you. At least, minimum. 2 to the power of 10, no? 2 to the power of 10 will give me minimum 1,000. It will be more than 1,000. We cannot write those 1,000 subnets in your notebook. The whole day you need to write. So, first 4 and last 4. If we know to write first 4 and last 4, then you know to write all 1,000 subnets. See, this is not important, but even like this, sometimes some universities ask. Sorry. Now let us go do this. 10 bits. Dot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These many bits are given for subnetting. See, whenever they say network or subnet, you should go from left to right. I have said, don't take 10 bits from here. Don't take from right side. Now 10 bits, this many. All the balanced bits are for the host. 1, 2, 3, 4, 5, 6. So how will you do subnetting? I'll teach you a shortcut which you may already know. If in case many bits are taken, you cannot keep writing 000 for 10 bits. Shortcut is, you see this bit. What is the face value of this? 64. Then you need to increment by 64. That's all. If you now see the homework, same thing. From where you give. If you're giving 3 bit, what is the value of this? 32. So you incremented by 32. Right? That's the shortcut. Here 10 bit, and this is in the third octet, higher order second bit. Second higher order bit, the third octet. So it needs to be incremented by 64. First network will be 10.0.0.0. This is the zeroth subnet. Second will be 10.0. In the third octet only 64 comes. 10.0.128.0. Next 10.0.192.0. We need to write first 4, no? But if you want to write the first 4 completely with the broadcast, first IP, last IP, I need to know the fifth one also. So 10.0. If I add 64 to this, it will become 256. But in an octet, how many you have maximum? 255. So if it is more than 255, means if it is 256, then 1 will come here and 0 will come here. That's it. 192 plus 64 is 256. So 256 means it will go to the next octet. The next octet you put 1. Did you understand this? Now, the first IP, okay, next will be 10.1.64.0. Again, it goes like that. When it comes to 1.192.0, next will be 2.0. Yeah. Fine. So let me write this. Broadcast IP here is 10.0. It's 10.0.255.255. If you add 1 bit to this, you will get this. So the first will be 10.0.192.1. The last will be 10.0.255.254. Okay, so this part is little bit difficult if you are doing for the first time, so focus. Ask question if you have. This is slash 10 plus 8. See, 10 is given, but the default is how much? Earlier we had 8, 8 plus 10. It's 18, slash 18.
So 10 bits given now, it doesn't mean that 8 plus
2. No. Given means the default is already there. It is given another 18, another 10 bits. Okay, next. Let us see how to do last 4. First 4, we know how to write. Let's write last 4 now. Last 4. 10.255.192.0 is what if all the bits are on. Do you agree? If all the bits are on, 10.255.192. How 192? 128 plus 64. Do you agree?
Yes.
All right. But we don't take if all are ones, right? Remember I told you in the previous class, if all the given bits are 1, we don't use. So this you just write it so that you can write the before one correctly, the last one correctly. 10 dot 255 dot this 192 minus 64 is 128 dot 0. This is the last subnet. 10 dot 255 dot, you need to just keep subtracting 64 from here because you're going up. When you're going up to down, you added 64. Now you need to subtract 64 if you're going from down to towards up. So this will be 64.0, 10.255.0.0, 10.254.192.0. You see, if I add one bit to this, I'm sorry, not to this. If I add 64 to this, I'll get 256. That is why I'm adding 1 here and putting 0 here. Same principle what I did here. Yeah. So we learned how to write the first 4 and last 4. You got last 4, you got first 4. See, again I'm repeating, this is not that important. In the real world we don't play, this is not a mathematics challenge. But some colleges, to make things tougher, they do all this. Right, so any question? Have you copied?
Sir, can you give one homework?
Yes, I'm going to give one homework. Okay. Please copy this if you want. And if you want me to do one more also, I can do. If you ask me to do another one, I'll do if you want.
Can you do one more, sir?
Yes.
Yes, sir. Let me almost பண்ணிக்கிறேன் sir.
Right, which one? First part or last part?
First part, last part போட்டுருங்க. First part.
Okay.
Hi, Mr. J, how are you? How are things? But today I went to Maya, I didn't see him. He's off today. So tomorrow I have to go again back to him because I want to take the exam, for data center design. I won't take the exam, just I want them to book for me the exam. But the problem before they book the exam, man, really I need the like terms from you. Just to study it, I want to prepare for it, and I want to be sure like that I will pass this exam. So please, I need your support. If you can find me the terms now for this course, just I want to be certified.
Right, so this is the question, 9 bits. And this is the new subnet mask. And this is what the solution. Incrementing 128 in the 4th octet. Because in the 4th octet only the 9th bit ends. If you want me to write another one, I can write, or if you have any question on this, you may ask. Or if you're okay, I'll give you one homework. Anyone wants me to write another one? One more? Anyone?
Fine, sir.
You're fine. One more? Anyone wants one more?
No, sir, clear with it.
You're clear? Okay. Okay, then I'm going to give you another homework. This is 192.168.0. Listen, 0, I'm putting this is class C, fully masked. 0.0 bits given is 4. 4 bits given. Now you need to write first 4 and last 4 subnet. Can you do first 4, last 4? Of course you can do, because you can have up to 16 subnets if you are given with 4 bits. You can have 16 subnets. I'm asking you to write first 4 and last 4. This is the homework. Later you can do homework. Let us now move on to another way of subnetting, meaning not another method. What if they don't give you the number of departments or number of bits given for network? Instead, they give you the number of hosts per department. For example, you have a LAN 1. Number of computers connected here is, let's say, 28 computers. And for the router, you need a IP address. So totally 29 addresses needed in this LAN. When you assign IP address to this interface of the router, it needs to be of same subnet. Only then it can become a gateway of all these computers. Okay, so totally 29 IP address in LAN 1. And I got another LAN LAN 2, where I don't have the same number. You see, in here I have maybe 55 computers plus 1, the gateway. See, the requirement is different. You may know here there are 2 departments, but not all the departments need same number of IP address. If you see in the above case, the number of IP address that you get in each subnet is going to be 126. How? You see, the first IP will be 172.16.0.1. The broadcast will be 127. And the last IP will be 126. 1 to 126. Same way here. Dot 129 is the first IP. The broadcast will be 0.256 is the broadcast. 255 is the broadcast. We don't use it as an IP. 0.254. So there also, if you see, 124 computers. 126 computers. 126 computers. You need to start from 9 itself. Include 9, then you will see 126. If you exclude 9, then it will be 125. You will. This is the first step. So include when you count. So here 1.1, 1.126. So here also 126 computers. So it is fixed number for each department. But we don't want the fixed number. We want variable length subnetting. This is what called as VLSM. Variable length will be there for each subnet because in each LAN you need different numbers of IP address. This is what we need in the real world. Most of the people will do subnetting like this. Variable length subnet mask. The number of bits you're going to give for host here will not be the same here because the requirement is different. Here I need 56 IP address. Here I need only 29 IP address. So the number of bits needed is not same. Then the subnet mask also cannot be same. Subnet mask depends on the number of bits that you're giving for network. Here, comparatively, this needs less number of bits for host than the other one. So because you need less host bits, you will go give more bits for the network compared to the other one. So the mask will be different for both. Will not be the same. The mask won't be same for both. We call this as VLSM. Let's see how to do it. It is very easy. You need to do two subnetting here. If I have more departments, for each department you need to do separate subnetting. Separate subnetting. Let's do. First, let us do this one. 29 IP address you need. See, this is not 29 network you need. You need 29 host IP. Means I need to take bits from right to left. Earlier, we were focusing on the subnet. When you talk about subnet or networking, the bits need to be from the left, growing towards the right. But now it is from the right to the left. Let me take a network first of all. I want to decide on a network. Let's say I want 172.0.0.0. This is what the network given for our company, assume. .172.0. This is already masked because it is class B. Don't touch this 0. Don't never change it. 1, 2, 3, 4, 5, 6, 7, 8. Now 30 computers. Sorry, 29 computers. If I take this 2 bit, what is the value I get? 2 plus 1 is 3. No, not enough because I got 29. If I take these many bits, 4 plus 2 plus 1, 7, not enough. Only 7. I need only 30 or 29 or 28, 29 or 30. So if I take these bits, I'll get 31. Say 16 plus 8 plus 4 plus 2 plus 1 is 31. Don't think I'm genius. I added very fast nothing. I'm not that genius. I did not add that fast. You see the next bit value is 32. If this is 32, then sum of all this will be 31. If this is 64, then sum of all this will be 63. You see? So you don't need to count every time. So you need this many bits for the host. Keep it. And from here, you're going to give for networking, which is same like what? 8 plus 3 bits given for network. 8 plus 3 bit given for network. 11 bits. You know how to do subnetting. You know how to do this. Okay. So the mask of this network will be slash. Can someone complete? 20?
27.
Very correct. 27. So do you understand how we come to this conclusion slash 27? We just keep the number of bits that we need and we give the rest. Now let us do subnetting. 172.0.0.0, 172.0.0.32, increment of 32 because the bit value is 32. 172.0.0.64 and goes like this. Don't keep on going. Don't do first 4, last 4 and all. See the requirement. You need only one subnet of this 29. So let us use this one. What will be the first IP? 172.0.0.1. What will be the broadcast? 172.0.0.31. This is not going to be used as IP because it's broadcast. The last is going to be 0.0.30. See, the first IP is 1, last IP is 30. You need about 29. So one IP address extra, it is okay. You are not wasting much. Just one extra. Maybe sometime you may add another computer. So you don't need to do again subnetting one more time because you got one extra IP address. So you know what to give for LAN 1. This is what we are giving for LAN 1. Next, move on to this one. 55 plus 1 IP. Let's do this. 172.0.1234567 8. 55 plus 1, huh? Yeah, 56. If I want 56, I need this many bits because sum of all this will give me 63. 63 IP address because the next bit is 64 here, right? If I take only this much, I'll get only 31, not sufficient. So I need this 6 bits. All right, this are all we are going to give for subnetting. I need the 6 bits for the host. So this is same like what? Giving 10 bits for networking. Giving 10 bits. And you're giving from this octet. Then the new mask means the subnet mask will be /26. You see, this is why you call it as VLSM. This is 26. The earlier one was 27. Variable length subnet mask. Variable length subnet mask is what you will use in the production so that you will not waste any IP address. You will not waste much IP address. Right, in the previous case, you just got only one address extra. If no VLSM, what you might have done is you might have done subnetting based on this info, and you would have got how many? You would have got somewhere around 60 plus IP address, And here half of the IP addresses would have been wasted because you need only 29. Right. Let's go here. 26 bits. And you know how to do. 172.0.0.0, 172.0.0.64, increment by 64. Don't use this. Why? In this, some addresses are already in use by other LAN up to 30, up to 31. So don't use this one. Even though the subnet mask is different, IP address will be same. How you will ping then? In both the departments, the IP address will begin with 172.0.0.1. That will not be possible for you to communicate. So don't use that one. So use this one. First network, first IP of the second LAN is 172.0.0.65. And then the broadcast will be .127. Last will be .126. You see how many you got? 62 IP address. You got 62 IP address. How many you need? 56. It is okay. It's okay. Not much wasted. Somewhere around 5 IP addresses extra. It is okay.
But this is a different LAN, right? This one's LAN 1 and LAN 2.
Even though it is LAN 1 and LAN 2, the IP address, if you give like this 172.0.0.1, here also 172.0.0.1, how you will ping from here to here? If it is same address, how you will ping? You understand?
So what is the device in between that is?
A router. Router will connect two different networks. Of course, this is two different networks. This is /27 network. This is /26 network. Router is ready to connect, but you cannot ping with the same IP address. Here, if it is 172.0.0.65, you will be able to ping. You can say go to 65. In this computer, if you say go to 172.16.0, sorry, 172.0, is it one? Yeah, 172.0.0.1, it will ping itself because this is also 172.0.0.1. Is it? You understand?
Okay.
So you cannot have a duplicate address. That's why we took second subnet. All right. So we don't use this one because this is already in use with the other one, other department. All right. If you understood this, I'm going to give you a homework. Or if you want me to do another one, I can do. What do you say? Do you want me to do another one?
I'm fine, sir.
Is everyone fine?
Yes.
Okay. Then the homework will be like this. Two routers. Router 1 connecting to a LAN. That router is connected via serial wire, point to point, which means you need only two IP address here. For this end one, for this end one. Only two IP address needed. And I got another LAN with some computers. Let me name this port as F0/0, F0/0, S0, serial 0, S0. And now we need Okay, the network is 10.0.0.0 network, and we need here only 15 IP. No, 10 IP. 10 IP plus this one, 11 IP. So whatever the subnet that you take, put the last IP here. Last IP of that subnet here. First IP of the subnet here. Alright? So you will do subnetting, right? When you do subnetting based on this info, 11 IP needed, you will get some subnet and you will decide on one subnet. In that subnet, the first IP you write it here for this computer. In that same subnet, the last IP you will derive not like this. The last IP, you give it to this interface, you write it here. The first IP, you write it here. Likewise, you will do subnetting based on this info. 2 IP needed. And you will get a subnet. Write the first one here and the last one here. Next. Here the number of IP address needed is okay. This I'm going to make a little complicated. But you try, give a try. If not, no problem. I'll help you when you come next. What I'm going to do is I need 300 plus 1 IP. 300 IP address means I have 300 computers. Give the first IP here and then the last IP here. So whenever we have VLSM, we will always try to do the bigger one first, and then we will go with the next bigger and then the smallest one. But in our previous example, I did not follow that because it was the first time I was doing. I did the small one first and then I went to the big one. Usually, we'll do the big one first and we'll give the first one for the biggest. But it is okay. It is okay. You can follow any method, small to big or big to small. You do anything.
On the network side?
What?
Network?
This is the network. 10.
Okay.
10.0.0.0. This is the network that you're supposed to use. Try. See, here is the last IP. Here is the first IP should come. All right. So let me also paste this in the chat window. I'll paste this. Right. Once again, thank you so much for joining. See you tomorrow. Take care. Welcome.
Thank you.
Welcome.